So, in continuation to my yesterday's class, today we are dealing current electricity, the second class. Okay. So, what is the objective of today's class? Basically, is we will now work something on the resistance part. Okay. 1 minute. Before I start with the resistance part, I just want to give you some clarity again. Yesterday, I have introduced the role of a battery and why battery is required. All that I have given you a detailed introduction to you. Now, please try to understand what is happening in case of a cell. I have clearly given you a brief description in my previous class. Now, you take a cell like this class. You take a cell like this. You have, we are representing the cell like this with its internal resistance outside. Now you are connecting this cell to some load resistance. This is our picture. Now, what I said, the battery mechanism now will drive a current I. Okay. Now these points A, B are this is also A, this is also B. Why? It's a conductor basically. Now the current that pass through, the load, capital R is I, and we call VA minus VB is equal to IR. This is from Ohm's law. Potential difference is equal to current into resistance. Okay. Now, which is say this is called potential difference across the cell. Across the cell. Right. VA minus VB can be written as E minus IR. This also I have given a detailed description in my last class. This is what you will call as a terminal PD. Terminal potential difference. Right. Now, please try to understand in this case, terminal PD is not the EMF of the cell because the cell is under discharge. So, therefore, E minus IR is equal to I capital R. Therefore, EMF is I times capital R plus small r. So, therefore, current is EMF by capital R plus small r. This is the fundamental relation, elementary level circuit approach. And never feel that if you connect a voltmeter, now I am representing like this. Now I am representing like this. Now, if you are connecting a voltmeter plus to here, a voltmeter minus to here, if you connect it like this is called a voltmeter. A voltmeter. Remember, it will measure terminal PD. It will measure terminal PD. So don't assume that it will show EMF. Can I ask you one question? When will it show EMF E? Anyone in the class? When will it show EMF E? You take the same circuit again. You take the same circuit again. Battery, internal resistance. The only difference is, say there is a key here. Now key is open. Will there be a current in this circuit now? Am I audible? Someone please confirm.
Yes, sir.
Thank you. Now, since the key is open, will there be any current that flows through the circuit? I didn't question you a difficult one. Actually, it's a simple, straight question. Actually, since it is a open circuit, there won't be any current flow. For the flow of current, the circuit must be closed. Here, circuit is open. No current will flow. Okay, fine. Now you take the same voltmeter here, voltmeter plus minus. Now again you connect A of the terminal A to the plus of voltmeter and the terminal minus of voltmeter to B. Now what will the voltmeter show? What is going to be the reading of voltmeter? Anyone in the class?
Sir, E.
Exactly correct, Harsha. I think you are the one who answered this, Harsha, right?
Yes, sir.
So therefore, now the voltmeter reading is E, which is EMF of the cell. So when will EMF of the cell is recorded? Simple, in open circuit condition. This is the principle which I have discussed yesterday totally. Okay, right. So now I have done a very basic part of the cell. Now after this, I need to go for the maximum power theorem. First of all, what is power? That you need to understand. What is power? When you are dealing with an ideal cell, internal resistance is zero. I know that. Otherwise, there will be, nothing is ideal in nature. You know that. Nothing is ideal. So, if not, it has some internal resistance. And that internal resistance depends on three things. Internal resistance of any cell depends on three things. One, nature of the electrolyte. Two, distance between the plates. Three, area of the plate. I repeat, the internal resistance of a cell depends on number one, nature of electrolyte. Two, distance between the plates. Three, area of the plates. Okay. Now you consider an ideal cell for a while. For a while, now this is the cell at an instant, say this much amount of charge is transferred through the loop, closed path. I am repeating, this much amount is transferred through this path, say between the 2 points. For God's grace, please help me. What is the potential difference between the 2 points. What is the potential difference between these 2 points? No one is answering. Arya, no one is answering. It is the EMF of the cell because there is no internal resistance, which means between these 2 points, across a potential difference V, you are transferring a charge. In electrostatics, we have learned work done is charge times the potential difference. Now, what am I doing? What is the battery doing at this instant? It is transferring a charge delta Q across a potential difference V. I am telling you again, all this is true if the internal resistance of the cell is considered to be 0. Okay? Right. Now the work done by the cell in transferring this much amount of charge is W is equal to delta Q into V. Right. Now what am I going to do here? I am now going to find the rate of doing work, which means dW by dt, which is nothing but dq by dt times V. Here V is the EMF of the cell. Don't forget that. Right. So therefore, power, rate of doing work is power. Don't forget that. So the power drawn or power delivered by the cell to the load here. In fact, where it will deliver? To the load. The power delivered by the cell is current into voltage. If you write V is equal to IR, it can be written as I square R. So now hereafter, the power delivered to a resistor R is expressed as I square R. Remember, when I am delivering power, after some time, what you will notice? The entire power delivered by me to the resistor is appearing in the form of heat. So all that power which you have delivered is now converted into heat. In fact, in heating instruments, if you are using a geyser, it is because of this part only you will get heat. The water in your geyser gets heated because of this particular part. So power is I square R. Now, any doubt till this point? Aditya, any doubt?
No, sir.
Sure. Soumya, పాఠం వింటున్నావా? Are you attending class?
ఎస్ సార్
నిన్నటి క్లాస్ విన్నావా?
ఒక హాఫ్ అన్ అవర్ సార్ మిగతాది ఈ క్లాస్ అయ్యాక వింటా సార్
రైట్, వెరీ గుడ్. నెక్స్ట్ ఇంకా ఇంకా Anish, are you listening to the class?
Yes, sir.
Nakshatra, are you following the class?
Yes, sir.
Till now, any doubt?
No, sir.
Very good. Next. Okay, sir, fine. What you said is for an ideal cell. Agreed. Agreed. Agreed, fine. What if the cell is not ideal? I repeat, what if the cell is not ideal? What will happen in this process? What will happen in this process? You will notice the battery need to do 2 different works. One, to maintain current through the load. Two, to maintain current through the internal resistance part. It has to do 2 things. It has to do 2 things. Number one, to maintain current through the external load, to maintain or to overcome the internal resistance. Whatever it is, the work done, rate of doing work instead of IV, I will write it as EI, EMF of the cell. Previously, for avoiding confusion, I have written V. Now I am writing E for the EMF of the cell. So the power delivered by the cell is EI. Just now I have given an expression. What is the expression for current? E by capital R plus small r. So therefore, the power delivered by the cell is E times E by capital R plus small r, which is going to be E square by capital R plus small r. So this is the total power delivered by the cell. And this power is dissipated in the form of heat, at R as well as small r. But this you cannot draw because it happens inside the cell. You can draw this part because it is external. Right. From this, I want to propose something called maximum power theorem. Okay? Maximum power theorem. What is our doubt? Sir, you have chosen some cell. Don't see this as a different thing, this as a different thing. I told you the entire thing is in one case, and that is called the cell EMF source of this circuit. Right. Now, this EMF source is delivering current I. Fine. And this current passes through the load. Fine. So the power delivered, just now I have given you the formula, I have derived this I square R, which is going to be E by capital R plus R whole square times capital R, which is going to be E square by this RR. It is purely power delivered across the load is purely a function of R. Please don't question me, why not a function of small r? Battery is fixed. I cannot change anything in the battery part. Okay. So what I can change is what you call the load part. Load means external resistance part. Now this is all mathematics. Now it is a function of R. I want to see when this function is minimum, when this function is maximum. For this purpose, you know already what we will do. Since this is function of R, I will differentiate with respect to R. By doing the differentiation, I will get this condition, capital R plus small r whole square minus capital R into 2 into capital R plus small r. So I will get this relation as capital R plus small r minus 2r is equal to 0, which means capital R is equal to small r. So which means when effective load resistance is equal to effective internal resistance, what happens? Power delivered will be maximum at the load. Now, if I plot a graph taking power delivered along y-axis, load resistance along x-axis, you will get a graph something like this. In fact, the peak corresponds to maximum power delivered. And it happens when external load resistance is equal to internal load resistance, otherwise. Okay. Now I'm asking you, this is a very famous theorem. You will get a lot of problems in mains exam also on the basis of this. Please tell me, have you followed it or not? Honestly. Sanjana, have you followed?
Yes, sir.
Deekshita, have you followed?
Yes, sir.
Harsh, have you followed? Yes or no?
Yes, sir.
Right. Next video రాలేదు ఇవాళ క్లాస్ కి. ఆదిత్య వచ్చావా క్లాస్ కి?
Yes, sir.
రైట్. నెక్స్ట్ వీడు రాలేదు, నాకు కనిపించట్లేదు ఇంకా. గౌరవ్ వచ్చావా?
Yes, sir.
Palvita, I think you were absent yesterday, if I am not mistaken. Just confirm whether I am right or not.
Yes, sir. I did not attend yesterday.
You are not there yesterday. Why?
I could not attend due to some network issue, sir. I was
Right.
outside.
Right. But I have posted the video link. Anyone have idea that I have posted this?
Yes, sir.
Have you gone through that link at least after the class?
Yes, sir. I did.
Right. Good. Next. Now our major deal is resistance in series and resistance in parallel. Resistance in series and resistance in parallel. All these things you already aware of at your school level only, but still I will make it bit faster so that I can accommodate good contents at a later stage. What is the meaning of the series circuit? See, resistance 1, resistance 2, resistance 3, they are connected such that it is the same current that flows through all the three. If we are giving such an arrangement is called as series. There should not be any split. Pakka, there won't be any split. Such an arrangement is called a series circuit. Right. Now remember, in this, current is same through all the resistors. If the current is the same, the potential drop, don't forget, potential drop is current into resistance. So V1 is to V2 is to V3 will become R1 is to R2 is to R3. And don't forget, across these 2 points, suppose if we are treating as A, you are treating as B, VA minus VB, you will write it as V1 plus V2 plus V3. V1 is nothing but IR1, V2 is nothing but IR2, V3 is nothing but IR3. As a whole, if you represent the entire, all the three together as one single resistance, it is R. So therefore, series equivalent resistance is R1 plus, R2 plus, R3. This is the general formula. R1 plus, R2 plus, R3. Right. What about parallel? In parallel, you should see that there should be a split. The major current that attends here gets splitted like this. I1, I2, I3. But remember, for all these resistances, this end is common and this end is common. All lefts are at one point, all rights at one point. Now, please confirm whether this is true or not. All lefts are at one point, all rights at one point. Means that the potential difference across each resistor is the same. Now what is going to happen? You said potential difference is the same. I into R is a constant. Means I1 is 2, I2 is 2, I3 is 1 by R is to 1 by R1 is to 1 by R2 is to 1 by R3. So therefore, if you ask me, I can write it as a current as I1 plus, I2 plus, I3. Don't say how. Because whatever the current enters, it is channelized into 3 tracks. If we add all, it should be the same as I. Law of conservation of charge. Right. Now, potential difference by R is potential difference by R1 plus, potential difference by R2 plus, potential difference by R3. So therefore, 1 by R is 1 by R1 plus, 1 by R2 plus, 1 by R3. That's the picture. 1 by R is equal to 1 by R1 plus 1 by R2 plus 1 by R3. This is called parallel equivalent resistance. And this is called series equivalent resistance. Okay. Now I'm just asking you again, my dear friends, have you followed this? You still have any doubts in this? Geetika, follow Enava?
Yes, sir.
Right. Sahasra, have you followed? Do you still have any doubt?
Yes, sir, I followed, no doubt.
Right. Next, Bhargav, Mahant, follow Enava? Any doubt? Next, Akshat, have you followed?
Yes, sir.
Right. Next. So therefore, these are all these that what I am discussing are fundamentals actually. Right. Next. Next is grouping of cells. So once I taught you series and parallel combination of resistances, my next view will be grouping of cells. Remember, all that which I am teaching even today is also basics. Only from tomorrow onwards, problems will start. Okay. Today, and even today, I will teach basics only. From tomorrow onwards, I will start problems and I will start giving homework from tomorrow onwards. But whatever that I am teaching, a very basic, please follow that. Why I am giving notes like this? Please try to understand. I am saving a lot of time. Right. In the grouping of cells, the first part which I am discussing is a series grouping. What is the meaning of a series grouping? I will take n cells, I will connect them in series, but please remember the order is important. In your childhood, you would have played a train game, very small, first class, second class. How you have played a train game? One boy will stand first, he is the engine, followed by compartments. See, backside part of the belt, the second person will catch hold of. The third person will catch hold of the backside belt of the second person, likewise. Here also, plus minus, plus minus, plus minus, plus minus, plus minus. In that order, I will connect n cells. First cell positive terminal, last cell negative terminal will be connected across a capital R. Here, capital R is called a load. You may ask me a question. Sir, why you have connected small r outside? Mahant, can you answer this question? Why you have shown small r outside? Otherwise, any student. But if his mic is not available, any student. Palvita, why you have represented small r outside? No student. I'm shocked to see. Aditya, why you have represented small r outside?
You have represented it outside because in order to indicate the internal resistance with the
Yes.
electromagnet.
Practically speaking, there is nothing outside. The entire portion, very good, Aditya. The entire portion is one single unit. It's a battery. The entire unit, left hand side is positive, right side hand is negative. So don't feel that battery is different, internal resistance is different. Right. Now for such a series connection, the entire series belt, you will represent it as an E. Why? All are in order. But similarly, each part is in series. All internal resistance, it is the same current that pass through all these resistors. Yes or no? Because it is the same current that pass through all these resistors, they are all in series. R1 plus R, 2 plus R, 3 plus R, 4 plus R, and all are smaller only. So therefore, it is NR. Here, instead of writing this much lengthy circuit, I have trimmed this one to a simple circuit like this. Right. Now what is the current through the load? I am worried about the load. So therefore the current is okay. What is that you want? You have a battery of EMF NE, internal resistance NR, and load resistance capital R. I see the same question as same as this relation. What I am going to do? NE by capital R plus NR. Fine. Now you take each cell now. Each cell. One such a cell. What is the, now let us take A, B for example. What is VA minus VP? Simply E minus IR. Already I have given you the basic. When the battery is discharging, the terminal PD is given as E minus IR. When the battery is under charging, terminal PD is given as E plus IR. Now E minus IR. Now in this, try to substitute the given data. By substituting this data here, I am going to get E into small r by capital R plus N small r. Okay? Fine. Suppose if there is no resistance. Suppose capital R is 0. If there is no load resistance. Simply you have shorted. Shorted ante, instead of this, you have shorted with a conductor. This end and this end is joined with a conductor. That is called shorting. Joined like that. What happens? Capital R becomes 0. If capital R becomes 0, terminal PD across each cell becomes 0. This is one important point which you need to know. Right. Okay. Fine. This is one important point. Next important point is, sir, done a small mistake. I know you asked me to connect in order plus minus, plus minus, plus minus, plus minus, plus minus, plus minus, and so on, n cells. But since I am reckless, so I have done some batteries wrong connection. What do you mean by wrong connection? Instead of plus minus, plus minus, plus minus, plus minus, somewhere you deviated. I am expecting plus minus, plus minus, plus minus, plus minus, plus minus, plus minus, likewise. Somewhere you have deviated. Instead of plus minus, you have connected minus plus, minus plus, minus plus, likewise. All that cells which you have connected with polarity different are wrong connected cells. Suppose by mistake you have done M cells like that. And M must be less than half of the total number. Why? It is as same as 10 pilgrims, a family of 10 traveled to some temple, and one student went to the phone inquiry, the mic station, stating that there are 9 passengers along with me who missed. వాళ్ళంతా తప్పిపోయారని చెప్పినట్టు ఉంటుంది. యాక్చువల్గా 9 మంది తప్పిపోవాలి, వీడే తప్పిపోయాడు. లైక్వైజ్ ఇప్పుడు 10 సెల్స్లో 6 రాంగ్ కలపకరు, ఎవరు 4 రాంగ్ కలపచ్చు. సో కాబట్టి అది జాగ్రత్తగా టెర్మినాలజీ పట్టుకోవాలి మీరు. రైట్ నౌ ఇఫ్ దేర్ ఆర్ M which is smaller than half of the total number, then you are connecting M cells wrong, means reverse connection. What is the consequence of this? It will have effect only on one term, the EMF term. For every one wrong connection, 2 cells will damage. Why? Simple. Plus minus, minus plus. Matash. It is becoming 0. 0. It has no contribution towards the EMF. For every one wrong connection, 2 cells gets damaged. Okay, fine. Then what happens? Sir, previously, when you have connected all in order, the EMF of the arrangement is n small n times capital E. Because you have connected M cells wrong, 2M out of M damaged. So how many cells are properly working now? N minus 2M. Only that number contributes EMF. So therefore, in that case, N minus 2M is E is a net EMF. Rest everything is the same. Whether you connect the cell flipped or order, it is the same path. Internal resistance remains the same. Whether you reverse or connected properly, it's the same path. Resistor ne it make. No issues. It's the same path. So therefore, no change in the internal resistance, no change in the load resistance. Only change is in the EMF part. Now current will reduce. So be careful in connecting series combination of the cells. Now I'll stop and I'll check whether you followed it or not. Anish, follow in a tena?
Yes, sir.
Pranati, follow in a?
Yes, sir.
Sahasra, follow in a?
Yes, sir.
Mahant, mic panjayatledu. Right. Akshit, follow in a?
Yes, sir.
Soumya, follow in a? Right. Right. Next. Now parallel grouping of cells. This is called parallel grouping of cells. This is called parallel grouping of cells. Which means each cell, again, don't, please keep it in your mind. Battery and internal resistance are not two different things. The entire thing is in one single box. All such boxes I have connected in parallel. Suppose there are N cells, all N I have connected in parallel. Now what happens? Let me see. In this case, what is happening here is all that represents one single source of EMF. Remember, they are not added. All are in parallel. So therefore, the effective EMF is still E only. But all internal resistances are in parallel. 1 by R1 plus 1 by R2 plus 1 by R3 plus, likewise you do, what happens? If equal resistances are connected, small r are connected in parallel, what happens? The effective internal resistance becomes R by N. Now the entire arrangement, what you see here, will now become a single source of EMF E and internal resistance small r by N. Fine. So therefore, now this is the arrangement. Rest everything is the same. Our own same formula, EMF by load resistance plus effective internal resistance. Now, sir, why you taught us two different things? Why you took series? Why you took parallel? Now I will explain. Suppose if the load resistance is very high when compared to the effective internal resistance. If the load resistance is high when compared to the effective internal resistance, you know what happens? Remember, in this case, you will simply ignore this. Yeah, A plus B, A is very high. A plus B is almost A. If, for example, this is 1,000, this is 1. Whether you add 1 or not makes no difference. So finally, it becomes E by R, parallel condition. What about the series? In series, this term will vanish because you said load is high when compared to the effective internal resistance. In that case, what is happening? Series current NE by R. Now tell me which is high? Series combination lo current ekku vastunda, parallel combination lo current ekku vastunda. In which case you are getting more current? In series combination you are getting more current. So therefore, if you face a situation like this, I prefer for more current, go for series. On the other hand, if load resistance is very small, I repeat, load resistance is very small when compared to the effective internal resistance, then what happens? You will now ignore this. Reverse case, no? You will now ignore this. you will get the current as NE by small r. Whereas in case of series combination, now you will ignore this. Now you will ignore this. What you will ignore is here in this. This is the term which you will ignore. Then what will happen? The equivalent current is E by R in case of series, NE by R in case of parallel. Now, which is dominating? Parallel combination current is high. So, why we take grouping of cells? Very simple. Effective internal resistance, effective load resistance is very high when compared to internal resistance. Then, for more current, prefer series. If the external load is small, very small, when compared to the effective internal resistance, for maximum current, prefer parallel. This is the options which we have. And usually in household purpose, when you are using inverter, the inverter usage is done according to these statistics. Okay, fine. In one case, I have taught you series. In another case, I have taught you parallel. What about mixed combination? Means some series, all such combinations parallel. For example, you take an arrangement like this. There are totally N1 rows. In each row, there are N2 cells. Means I have totally how many cells? I have totally N1 to N2 number of cells. Totally number of cells. 86. Likewise, 8 into 6. Likewise. 48 cells I have. There is one combination I can use 8 into 6. 8 in each row. Likewise, 6 rows. I'm just giving you some example. Not necessarily that is the final case. Totally, I have N1 into N2 number of cells. What am I doing now? In each row, I am taking N2 cells. Likewise, I have N1 rows. Fine. The entire, hello, all this is in one box. All this is in one box. Now, if all this is in one box, what is the effective EMF? Very simple. Each row will now behave as a single source of EMF N to E, and total row resistance is N2 smaller. So I'll draw an intermediate. Each row behaves like a source of EMF N to E and internal resistance N to R. Okay. Now what is happening? There are N1 such rows. Okay. Each row now behaves like a source of EMF N to E and internal resistance N to R. Likewise, how many you have? N1. Very simple. EMF still remains N to E and effective internal resistance becomes N2 by N1R. And this entire box can be replaced with a single box. What is that? N2E EMF, N2 small r by N1 internal resistance. And this entire thing is connected to the load capital R. What is the current? Same formula. Whatever I taught, E by capital R plus small r. So EMF by load plus internal resistance. So this is the current through the load. So why you taught this? Okay. What if I want a maximum current condition? What is the condition for maximum power? Maximum power theorem. What do maximum power theorem suggest? Effective load resistance is equal to effective internal resistance. So therefore, in this, effective load resistance is this term. Effective internal resistance is this term. If you equate both, you will get maximum current through the load or maximum power is delivered across the load. Okay, right. Now, I am asking you, till this point, do you have any doubt? Do you have any doubt till this point? Arya, do you have any doubt till this point? Harsh, any doubt till this point?
No, sir.
Okay, Gaurav, any doubt till this point?
No, sir.
Sanjana, do you have any doubt till this point?
No, sir.
Right. Now I am going for the next cases. All this is basic theory. Right. You will get majorly such questions in mains. ఇంకా అసలు I didn't touch the advanced part. I am still at the basics. Now you take the case 1 of the given figure. What is the given figure? Till now I have used ideal similar cells, identical cells. All are of EMV, all are of internal resistance R1. Fine. Now I am using different combination. I have two different cells, E1, E2. EMFs E1, E2. Internal resistance small r1, small r2. Fine. They are connected in series. Even though they are connected in series, you should never confuse one part here. Are they driving currents in the same sense or not? How do I know? Minus plus. Order dekho. Everyone, please see the order. Minus plus means both will drive the current in the same sense. In that case, the effective EMF gets added, E1 plus E2. Of course, path is the same, R1 plus R2, small r1 plus small r2. So it is equivalent to, according to me, this is equivalent to a single cell of EMF E1 plus E2 and internal resistance R1 plus R2 connected to the load capital R. Okay. So what is the current? Our general formula just now I have given EMF by load plus internal resistance. So that's what we have done here. EMF by load plus internal resistance. Fine. Now, what is the potential drop across each cell? Each cell here is discharging. When the cell is discharging, I told you, what is the potential drop across the cell? E minus I small r. So, therefore, potential drop V1 is equal to E1 minus IR1. E1 minus substituted this over here. Okay. By just substituting this one here, finally, I will get a condition as V1 is equal to this part. Similarly, you go with the V2, no issues. Okay, no issues. You go with the V2. What you will get as V2, I'll just looking at the face of V1, I can say E2 capital R plus E2 small r1 minus E1 R2 by capital R plus small r1 plus small r2. No issues. One, if you know, you can write other. Right. But I just want to take a confirmation before I go further. Now, please tell me, have you followed this or not? Have you followed this or not? Mahant, have you followed? Right. Next. Sai Bhargav, someone raised hand. Any doubt? Please raise your hand. No issues. Anyone having doubt? Pakka? Geetika, follow Enava?
Yes, sir.
Nakshatra, follow Enava?
Yes, sir.
Asini, follow Enava?
Yes, sir.
Right. Next.
Sir,
Yeah. Ask me.
sir, when the current enters into the negative terminal, then it is discharging.
No, I'll explain. If you see your battery is like this, if the current flows like this, that is considered as discharging. Suppose if you see the cell is like this and the current flows like this inside the battery, if the current is from positive terminal to negative terminal, that case is called a charging. This case you will call it as a charging of a cell. Inside the battery, if the current is from negative terminal to positive terminal, inside the battery I am asking about, then it is called discharging. Tell me, am I cleared your doubt? Yes or no? Just honestly.
Yes, sir.
Very good. Thank you. Next. Right. Next question, case 2. Case 2. Okay, fine. I don't see any difference. Do you see any difference in case 1 and case 2? Anyone in the class?
Sir, parallel.
No. They are still in series. Palvita, what is the difference that you have noticed from case 1 versus case 2?
Same terminals are means
Which means they are not in order.
parallel or series.
No, they are all in series only.
But terminals are in same side.
Terminals are same side means it is not in order. Minus plus la లేదు. Then what happens? One battery will maybe, I have no idea unless or until I don't give you any information. Say for example, E1 greater than E2. The one with the highest EMF will discharge. The one with the least EMF gets charged. In such a case, EMF you should not take as E1 minus E1 plus E2. In fact, you should take it as E1 minus E2. Rest everything is the same. Why? Because now say I am drawing the circuit again. You will represent this as E1 minus E2, but the path is still the same. Smaller load resistance, capital R. Now, accordingly, you will write the expression for current like this. Remember, yet one battery here, it is discharging. Here, it is charging. So, what is the terminal PD there? E1 minus IR1. I am doing all substitution. Finally, I got V1 is equal to this relation. Please see the difference. Same V1, same V1. You have a minus sign here, you have a plus sign here. Okay? Similarly, you can find at other cell also. Now, please confirm, have you followed case 2 or not? Are we clear with case 2? Yes or no? Akshit Manohar, have you followed case 2 clearly?
Yes, sir.
Soumya, have you followed case 2 clearly?
Yes, sir.
Very good. Next, Devansh, have you followed case 2 clearly?
Yes, sir.
Yashwant, have you followed case 2 clearly?
So, yes, sir.
Right. Next. Aryar, this is series only. This is also series only. Only difference is polarity is different. Now I will take completely a different case. This I will teach it after teaching Ohm's law. No, after teaching Kirchhoff law. No issues. Now heating effects of electric current. Just simple topic. Basics first person. So that you will go for doing problems. Heating effects of electric current. I mentioned very clearly, when a current passes through the resistor, in fact, a battery has to deliver power to maintain current through that resistor, and that power is given as I square R. I just told you very clearly that while I am maintaining this current, I am delivering some power to the resistor. What happens to the power delivered to the resistor? The entire power converts into the form of heat. In fact, on the basis of this principle only, some instruments will work. For example, our household geyser works on the same principle. Soldering rod works on the same principle. Fuse wire works on the same principle. Cloths, pressing చేయడానికి use చేసే iron works on the same principle. So your geyser, soldering rod, fuse wire, iron, all these things works on the same principle, heating effects of electric current. Okay. So what is the basic principle? Whatever the power delivered, it is written as I square R or VI or you write whatever it is. I is equal to VI R means V square by R. Three forms. I square capital R, I into V or V square by capital R, whatever it is. Suppose this is the power delivered, right? So suppose you have passed this current for a time T, then power into time, heat. I square R into T gives heat. So actually, why there is a heat? That's all. That also we should check. Yes. Why there will be heat? Why we are observing heat? Then go back to the first class. The very basic treatment of current. What exactly is a current? It is due to the drifting of electrons. In the process of drifting of the electrons in its motion collides with either an electron or the ion which is attached to the crystal inside the solid. For every collision, what happens is the amplitude of oscillation of this ion increases. Ion won't move. Ion is fixed, static, fixed rigidly to a lattice point inside the crystal. But because of the collision, it moves with greater amplitudes. As it vibrates, it gives out the energy, excess energy in the form of heat. Now, as these electrons in conductor undergoes collisions with ions, the atoms, what will happen is they will transfer some energy to that ion and that increases the amplitude of oscillation or amplitude of vibration of these ions. Three, what is the temperature? What is internal energy? In heat you have studied. In case of internal energy for a gas, it is due to random motion of the molecules, translational as well as rotational. Whereas in case of solids, it is due to vibrational energy, oscillational energy of these ions. More high is the amplitude, more high is the temperature. Remember, whether it is a direct current or alternating current, if passes through resistor, you will observe heat evolving out from that resistor. But before you do problems, you need to note some basic conversions. In heat, most of the times calorimetry, we have done answers in terms of calories. For example, latent heat of fusion of ice, you say 80 calorie per gram. Latent heat of vaporization, you will say 540 calorie per gram. But in current electricity, mostly we do in SI systems. So therefore, wherever you see calorie, you should convert into joule. 1 calorie is nearly 4.2 joules. Whereas in current electricity, every house we have fitted with electric meters. You know, you will say that your mother or father will say this month we got 300 units. The current which we have used is 300 units. What is a unit? 1 unit is called a kilowatt hour. Kilowatt hour. Kilo means 1000. Watt hour means 36,000 seconds. So totally this is 3.6 into 10 power 6 joules. మనం కమర్షియల్గా యూజ్ చేసే మీటర్స్ 1 యూనిట్ అంటే when you are using 3.6 into 10 power 6 joules, the meter shows that you have used 1 unit. Okay, right. Next, suppose any time if they give you that the power wattage of an element is P, usage time usage is T, P into T is the energy that we have obtained from this external instrument. External means electricity, Department of Electricity. How many units consumed? Very simple. P into T by this factor that converts into kilowatt. Right. Now, only this is all a very basic. All these things you would have already learnt in school actually. But just I told you yesterday's class as well as today's class, we'll focus on basics. Now, suppose if the resistors are connected in series, through each resistor current is the same. But power delivered across each resistor not necessarily the same because it depends on resistance. So power delivered I square R1, I square R2, I square R3. More high is the resistance, more high is the power delivered. The greater the resistance, greater will be the power delivered. Whereas in case of parallel combination, potential drop is the same across each resistor. మనకు రెండు ఫార్ములాస్ ఉన్నాయని చెప్పాను నేను. I square R, V square by R. Now power across the first one is V square by R1. Power across the second resistor is V square by R2. Across this is V square by R3. Now tell me, least denominator, more high is the fraction. So least resistance, the path along which resistance is least, power delivered will be high. So lowest the resistance, greatest will be the power delivered. Now I'm asking you again, do you have any doubts in this particular part of theory? Please confirm. Sanjana, have you followed both series and parallel combinations of resistors in terminology of power?
Yes, sir.
Palvita, have you followed?
Yes, sir.
Right. Tanush, have you followed? Tanush.
Yes, sir.
Very good. Anish, have you followed? Aditya. Aditya,
Yes, sir.
follow. Right. Good. నెక్స్ట్ మళ్ళీ నేను మళ్ళీ బల్బ్స్ దగ్గరికి వాటి దగ్గరికి తర్వాత వస్తాను నెక్స్ట్ క్లాస్. నెక్స్ట్ ఇదంతా రేపు డిస్కస్ చేద్దాం మనం. రైట్. నో ప్రాబ్లమ్స్ విల్ స్టార్ట్. Everyone try to note this. This is a very, 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 very elemental question. In fact, you will find such question even in Pathfinder also. So that the total amount of charge at the junction of the two materials in this figure is so and so, where I is the current flowing through the junction, sigma 1 and sigma 2 are the conductivities of the two materials. Sir, what do you want to ask? See, for example, in our electrical connection, you are using two wires. For example, I am using wire 1. This is wire 1. And this wire is say made of a material A, followed by I am using another wire. For a while, assume the dimensions are cross-sectional area is the same, and this is made of material B. The problem is they are different materials, so they have different resistivities or conductivities. So what? Remember, current is the same through all. It is the same current that pass through all. What is current or current density? Current density is NEVD. The problem is, can I ask you one question? Sahasra, A lo N value, B lo N value same untunda, different untunda? A lo N value, current density formula small n term. A material lo N, B material lo N same untunda, different untunda? Anyone? Anish, Aditya, Mahan?
Same, sir. Same number of L.
How do you know it is the same?
Because current flowing is the same, no, sir.
Array,
With both
this
the
is what I
materials.
told here. Yesterday's class when I told n,
Sir,
what do n represents? Bhargav Japara, Manth Japo.
sir, if the number of electrons are passing through the same area of cross section, then
Wrong,
the n is same, sir.
wrong. You didn't follow yesterday's class. N represents number of free electrons per unit volume. ఇప్పుడు చెప్పండి n ఏలో సేమ్ బిలో సేమ్ ఉంటుందా?
That only, sir. If the area or the volume is same, then only the n is same, right, sir?
Wrong. N represents number of free electrons available per unit volume. It depends on nature of material. For material A, N is different from the material B. For material A, N is different from material B. Now you please tell me, in the same question, even though current density is the same, now tell me, will N be the same for both the materials? Different materials will have different, what you call, conductivities and resistivities because different N's, different structures. So therefore, they have different N. So if to maintain the same current or current density, what has to happen now? Month. What has to happen? To maintain the
Sir,
same
can you
current.
repeat the question?
It is very clear N is different for material A and material B. Accepted? Because N is purely a property of material. Copper can value where, brass can value where, silver can value where. N is the characteristic property of the material. The Young's modulus ఉంది అన్నిటికీ ఒకటే ఉండదుగా. Different materials will have different Young's modulus. N కూడా అంతే. బట్ కరెంట్ డెన్సిటీ కాన్స్టెంట్ కావాలి రెండిటిల్లో అంటే ఏమై ఉండాలి, ఏమయ్యాలి? వాట్ షుడ్ బి ద కండిషన్? హర్ష్ టెల్ మీ. హర్ష్ చెప్పరా, ట్రై చేయి, తప్పేం లేదు.
సార్ మెటీరియల్ వన్ లో రెసిస్టెన్స్ పెడితే
You did not understand my question. It is the same current that is passing through A and B. A లో పోయే current, B లోకి పోయే current same because they are in series. But N, nature of material of A is different from nature of material of B. N is different. Small n term is different. How is it possible to maintain the same current in A as well as B?
Same resistivity.
When I said material of A and B are different, how can you say same resistivity here? I'm very surprised. I'm very clear there is no option for you at all. I said A is a different material, B is a different material. In such a situation, how is it possible to maintain the same current density when N is different?
The drift should be same of the electrons.
Harsh, Chapo, Harsh.
సార్ ఐ డోంట్ నో.
Anyone in the class? No one? Ariyar. Palvita, you can't answer this?
The drift of the electron should be same. I mean, should be.
Drift velocity must be different in both A and B. అంటే ఏలో డ్రిఫ్ట్ వెలాసిటీ, బిలో డ్రిఫ్ట్ వెలాసిటీ డిఫరెంట్గా ఉండాలి. ఫర్ ఎగ్జాంపుల్ ఎన్, ఫర్ ఎగ్జాంపుల్ ఐఎమ్ జస్ట్ టెల్లింగ్ యూ, ఎన్ ఇన్ ఏ ఈజ్ హై ఫర్ ఎగ్జాంపుల్. Automatically, the moment when I go to B, it should have a sudden rise in drift velocity. When is this possible? It is possible only when there is an accumulation of a charge at the junction. So this you need to understand. So whenever there is a junction like this, automatically there will be an accumulation of charge possible. Why? Because when an electron crosses the border, for example, an electron in this case, if an electron in this case moving here with, I am just giving you just simple number. Say, for example, an electron in this case, say moving with 10 centimeter per second, and an electron, when it just goes here, suddenly need to become 8 centimeter per second, means there should be some accumulation of charge over here. What is the role of the accumulated charge? Because the charge is accumulated over here, this charge will decelerate the motion of the electron so that the drift velocity is reduced. So therefore, accumulation of charge is mandatory to change the drift velocity to maintain the same current, right? So let us study in detail. Do you remember yesterday I have given this relation? Resistivity is this. Reciprocal of resistivity is conductivity. Do you remember all these relations? Yesterday only I have given. After the end of this class, I will post the notes. This is resistivity and this is conductivity. Conductivity. So I am taking sigma 1 greater than sigma 2. Right. Here it was given here. Why should I take? They have given the condition here. Sigma 1 greater than sigma 2 means N1 must be greater than N2. That's what I told you just now. If N1 is greater than N2, means VD2 must be greater than VD1 automatically. Automatically. To maintain the same current density, the drift velocity must increase once you cross from this region to this region. Right. Right. And number 2, don't forget Ohm's law. I have given this relation. E is equal to rho J or E is equal to J by sigma. E into sigma is equal to J. Remember, current density is the same. So E1 rho 1 is equal to E2 rho 2. Right. Now you apply, I am now assuming, yes, there should be charge across the border because E1 and E2 are difference. If you permit me, I will write E2 minus E1 as 1 by sigma 2 minus 1 by sigma 1 J. 1 by sigma 2 minus 1 by sigma 1 J. You may question me, how do you know E2 is greater than E1? Arya, don't be foolish here. You told me just now sigma 1 greater than sigma 2. When sigma 1 is greater than sigma 2, E2 must be greater than E1. So therefore, E2 minus E1 can be written like this. Right. But Gauss law says, if there is a charge accumulated here, E2 minus E1, Gauss law states, Gauss law, E2 minus E1 times A is 1 by epsilon naught times the charge enclosed. This is as per Gauss law. So therefore, I am applying the Gauss law over here. So Q enclosed by epsilon naught S is equal to 1 by sigma 2 minus 1 by sigma 1 times J. So Q is epsilon naught times 1 by sigma 2 minus 1 by sigma 1 times J into S. Are your current density into cross-sectional area? What you will get? Current. Therefore, charge Q is equal to epsilon naught. Charge Q is equal to epsilon naught 1 by sigma 2 minus 1 by sigma 1 times I. So that's the charge. Okay. So what is that you are asking me? Charge accumulated. That's what I have proved. Here, that's what I have proved. So whenever hereafter you see that when there are two resistors connected in series, remember, even though current is the same, not necessarily drift velocity will be the same. drift velocity more or less is decided by n factor. You should remember this. What best I know is if they are of same cross-sectional area, I can write it like this. Very important observation. చూడండి ఇవి ఫార్ములాస్ కాదు, ఇది కాన్సెప్ట్. ఇప్పుడు రేపొద్దున మీరు ప్రాబ్లమ్స్ చేసేటప్పుడు క్వశ్చన్ మార్క్ ఫేస్తో చూస్తారు కొన్ని. ఇది ఎలా వచ్చింది, ఎందుకు జరుగుతుంది అంటే వై దిస్ హ్యాపెన్స్ వైల్ లెర్నింగ్ ఇట్ సెల్ఫ్ యూ విల్ పుట్ ఏ ఫిల్టర్. ఈ ఇంటర్మీడియట్ లెర్నింగ్లో లాగా 5 క్వశ్చన్స్లో 4 నేర్చుకుంటే చాలా అన్నట్టు మీరు ఇక్కడ చాయిస్ పెట్టుకుంటే యూ విల్ నాట్ లెర్న్ ఆర్ యూ విల్ నాట్ డూ ప్రాబ్లమ్స్. సి ఎంటైర్ 2 days I have just introduced one question. Remember how much time I am spending on basics. Series connection, this is the criteria. You should remember this. Similarly, parallel connection. Yeah, parallel connection. Current splits. I1 is given as N1 E VD1. I2 is given as N2 E VD2. Then ratio of currents are decided by this part factor. So series, what is happening? Decided by this factor. Parallel, what is going to happen is decided by this factor. Suppose if they are of same material, N1 becomes N2. So I1 by I2 is same as ratio of drift velocities. So please confirm whether you followed this concept or not. Sanjana, have you followed this concept? Sanjana.
Yes, sir. Yes,
Uh,
sir.
right.
Yes, sir.
Please be louder. Next, Gaurav, have you followed?
Yes, sir.
Kavita B, have you followed?
Yes, sir.
Right. Devansh, have you followed this concept?
Sir, yes, sir.
Right. Next. Now we will work on deriving. Till now, when I said resistance, what stood in your mind is a wire, a uniform wire, whose resistance is rho into, for a uniform wire like this, say in the form of a cylinder. This is how you have the cylinder, whose length is L, whose cross-sectional area is A. Then you will equate this to a resistor of resistance R given by rho into L by cross-sectional area, rho into L by area. Whenever I said resistance, this is what that stood in your mind. True, this is for a uniform conductor. What if the conductor shapes are different? So what is the first step? Truncated cone. What if the conductor is like this? What if the conductor is like this? Whatever I see here, I will feel this conductor like a cone here, truncated cone, cut perpendicular to the axis. You will see discs, disc. In a Poppins packet, all the Poppins are a polo, for example. All polos, same radius. But this is truncated cone. From one end to another end, the radius gradually increases. But basically, they are all discs. You take one such element here. So I took one such element here. one such element here, like this, whose thickness is dx, which is at a distance x from this end. Right. Please try to understand. I want to find only the resistance of this element for a while. But geometry is required. You see, geometry is required there. Now you see, this is the axis of the cone. Okay. One end, the radius is R1. The other end, the radius is R2. Now this is how you have the slope. And remember, at this end, what is going to be the radius? Say this is R. Remember, this is X. And total length is L. Then you will use formula. What is that formula? R2 minus R1 by L is equal to R minus R1 by X. I think you know this. Geometry. But that is the reason why, for my convenience, I am taking the radius of this as Z, which you call it as R here. Like, for example, you call it as Z, for example, no issues, Z. So Z can be written as, this is nothing but tan theta actually. The entire term is tan theta, tan theta. So Z minus R1 by X is tan theta. So Z is R1 plus tan theta X. Now let us find dz. What is dz? Tan theta dx. Right. Just stay there. I want to find the resistance of this element alone. What is the general formula? Resistance, resistivity, length, cross-sectional area. Okay, length of this element is dx, written. Area of this element is pi r square, pi z square, z square, written here. Okay. Now, an element is having this much resistance. Can you please tell me how are these elements from this point to this point? Anyone in the class? How are that element? Means, are they in series or are they in parallel? All such elements. Series or parallel. How are they? Darshan, how are they? Kitika, how are they? How are these elements from the left hand to right hand?
Sorry.
No one. Sanjana, Gatiga Jepo. How are these elements? No one. Surprise. Mahant, how are these elements? From left hand to right hand. Series lo unnaya, parallel lo unnaya, okkokati. Anyone in the class, you are free to answer this question. Aditya, how are these elements? From left hand to right hand. ఇలాంటి ఎలిమెంట్స్ ఉంటాయి కదా మీకు. All these, you can take one element here, next element here, next element here, next element here, next element
Series.
here. Yes, exactly. They are all in series. So therefore, R1 plus R2 plus R3 plus R4 plus Rn finite elements కైతే చేస్తారు. Infinite small addition ఏమని పిలుస్తారు? Integration. And now I am integrating all that elements from 0 to L. That I am doing this. After doing the integration, you will get the condition as a capital R is equal to rho L by pi R1 R2. Okay. See, derivation is okay. It is good to remember. Otherwise, what happens is in exam, you are supposed to derive. And again, I'm asking you, any doubts in this? Any doubts? Palvita, do you have any doubt in this? In my derivation part?
No, sir.
Sahasra, do you have any doubt?
No, sir.
Rahman, Abdul Rahman, do you have any doubt? Abdul Rahman. Devansh, any doubt?
Sir, no, sir.
Very good, fine. All this is about a truncated core. Means current starts here and reaches here. Remember, one point everyone need to accept. Current is the same through every cross section. For example, you take one cross section over here. You take one cross section over here. You take another cross section over here. At this cross section, drift velocity is V1. At this cross section, drift velocity is V2, which is higher. Among V1 and V2, which is higher. Remember, current is the same. NEAVD. Entire material is the same. So N is the same for all. E is the same for all. Is A same for every cross section?
No.
No. So therefore, it is like equation of continuity. So at this point, cross section is less. At this point, cross section is high. So therefore, as you move from left to right, lower cross section to right, rightward cross section, drift velocity decreases. To maintain the current to be same. Okay. Clear? Next. Next, resistance of a thick spherical shell. Not sphere. Thick spherical shell. Inside radius is A, outside radius is B. So current flows from inner surface towards outer surface. That is how current flows. Right. Let us work on the resistance of this. Obviously, by this time you have understood. We will take one thin shell, one such thin shell. One such thin shell. Fine. Areyar, how the current goes? Don't forget how the current goes. The current goes through this in different ways. Radially outward. Through every shell, radially outward. It is the same current that goes through every such thin shell. Then, first, let us speak about only one shell. One shell, what is the resistance? General formula, resistance, length, cross-sectional area, rho into L by A. Here in this case, what do you mean by length? dr is the length. What is going to be the surface area? 4 pi r square is the surface area. So the resistance of this elemental shell, is this. Now, how are all such shells from center towards the surface? From innermost edge to outermost edge. How are they? Boys, how are they? Series or parallel? Series. Why? Because it is the same current that flows through every shell. Again, infinite small addition. A to B, dr. Now, what is that you are going to get? Integration of this. RR 1 by R integration is 1 by A minus 1 by B. That's it. So, resistance of the thick spherical shell is expressed like this. Any doubts? Ask me right now. Any student having doubt? Aditya, clear or any doubt?
Clear, sir, no doubts.
Right. Anish, P. Anish, do you have any doubt? Right.
No, sir.
Soumya, following?
Yes, sir.
Right. Next. Resistance of thick cylindrical pipe. The problem with cylindrical pipe, current can go in two different ways. One, along the axis. Two, radially outward. Along the axis is the most simple case. Why? General formula, resistance is equal to rho into L by A. I am going to use the same rho, L, only difference is area means pi A B square minus A square. If the current is flowing through the axial direction, the resistance of this bit is given as rho into L by pi B square minus A square, most easiest case. Now here, how the current is flowing? Radially outward, in spherical symmetry. Now in cylindrical symmetry, what if the current flows radially outwards? Simple. ఇందాక మనం శాంపుల్ పీస్ ఏం తీసుకున్నాం, స్పియర్లో షెల్ తీసుకున్నాం. ఇక్కడ ఏం తీసుకుంటాం? యూ విల్ సింప్లీ టేక్ ఎ పైప్. వాట్ ఈస్ ద పైప్? వన్ సచ్ పైప్ ఆఫ్ రేడియస్ ఆర్ అండ్ థిక్నెస్ డిఆర్. రెసిస్టెన్స్ రాస్తారు. డిఆర్ ఈజ్ ఈక్వల్ టు రో ఇంటూ డిఆర్ బై, ఇప్పుడు ఈ పైప్ ఏరియా ఏమని రాస్తారు? దిస్ ఇస్ ఆర్ అండ్ దిస్ ఇస్ లెంగ్త్ ఎల్. వాట్ ఈస్ ద ఏరియా ఆఫ్ దిస్ curved part? 2 pi r into L. అంతేగా. మ్యాట్ చుట్టేస్తే 2 pi r into L. 2 pi r into L. How are these pipes? Series. So infinite small addition. So you are doing integration of this. Finally, you will get rho by 2 pi L into log E P by A. These formulas you may use in mains examination. In advance, they won't ask anything related to this. If required also, you will derive. But in mains, you will have a number of questions, more number of questions. So you should remember this. అదే ఒకసారి మీరే డిరైవ్ చేశారు అనుకోండి, ఇవాళ ఈవినింగ్ నేను నోట్స్ పెడతాను మీరు మీకు. ద మూమెంట్ వెన్ క్లాసెస్ ఆర్ ఓవర్ బై ఈవినింగ్, automatically what you will do? You will, you will do these derivations again by your own. Then automatically you will remember this forever. Okay, so all these are basic parts. Now everyone go through this question, and this will be the last question for the day. So therefore, everyone please go through that question. Everyone please go through that question. In our VAT examinations, regularly our people will ask these questions. Please go through the question, everyone. A conducting open pipe has a shape of a half cylinder. It is a thick pipe. Its semicircular cross section has a radius R. Okay. Thickness T. The resistance of the conductor when the current enters and leaves as shown. No issues. In this case, length is known. Area is nothing but 2 pi RT. No, pi RT. Why pi RT? Only half. అరే ఈ ఆర్క్ ఎంతరా? ఈ ఆర్క్ లెంగ్త్ పై ఆర్. ఈ షేడెడ్ పార్ట్ ఎంత?
T pi r t.
ఏరియా పై ఆర్ టీ. లెంగ్త్ ఎల్. సో రెసిస్టెన్స్ ఏమని చెప్తారు? రో ఇంటూ ఎల్ బై పై ఆర్ టీ. డన్. ఏ కేస్ చెప్పేశారు. బి కేస్ ఓకే. బి కేస్కి నాకు లెంగ్త్, బి కేస్కి ఏరియా ఫస్ట్ కట్టాలి. ఈ కేస్కి దానిదే ఉంది, కట్టేస్తా. This is of length L, and the shaded part is of thickness T. Can you please tell me what is going to be the area now? L into T.
LT.
Mar length of the path, ERK, pi R. In
Pi
that,
R.
the resistance is rho into pi r by LT. Okay? So very simple. Only thing that you need to identify is the resistance part or the calculation of length part and area part. Okay? Now just please, for my confidence, tell me, have you followed? Yes or no? It is 3 or 4 students. Please. Have you followed or not? Arya, ఒక్కడు కూడా చెప్పకపోతే ఎలారా? మహంత్ ఫాలో అయినావా? ఆదిత్య ఫాలో అయినావా?
Yes, sir.
మరి చెప్పాలి కదరా, ఆడెవడో చెప్తాడు, నువ్వు అవుతాయి ఎట్లా? నీ టైం కూడా వేస్ట్ అవుతుంది ఇప్పుడు. అనీష్ ఫాలో అయినావా?
Yes, sir.
నెక్స్ట్ సహస్ర ఫాలో అయినావా?
ఎస్ సార్.
రైట్, ఫైన్. ఇప్పుడు మీరు అడిగారు కదా, ఇప్పుడు ఈ క్వశ్చన్స్ ఎట్లా ఐఐటికి కన్వర్ట్ అవుతాయని. ఫర్ ఎగ్జాంపుల్ చూడండి, ఇలా రావచ్చు క్వశ్చన్ మీకు 50 క్వశ్చన్ లాగా. ఇది నేను రేపు డిస్కస్ చేస్తాను. ఇప్పుడు ఒకసారి ఐఐటీలో ఇచ్చారు ఇట్లా, ఈ షేప్ ఇచ్చాడు ఇక, ఇదిగోండి. ఇప్పుడు ఇది కడతాం. చూడండి, మీరే చూడండి. అంటే బేసిక్ తెలిస్తే క్వశ్చన్ చేస్తామంటాను నేను. ఇది ట్రై చేయండి. ఇది ఎలా ఉంది? ఇది ప్రీవియస్ ఐఐటి క్వశ్చన్. ఇన్ ఎన్ అల్యూమినియం ఏఎల్ ఎన్ ఐరన్ బార్ ఇన్సర్ట్ చేశారు. ఒక రెసిస్టివిటీస్ ఇచ్చేశారు మీకు. ది ఎలక్ట్రిక్ రెసిస్టెన్స్ బిట్వీన్ 2 ఫేసెస్ పి అండ్ క్యూ ఆఫ్ ద కాంపోజిట్ బార్ ఈస్ అని అడుగుతున్నారు. నేను ఒక్క విషయం అడగదు సార్. ఇప్పుడు కరెంట్ ఎలా పోతుందంటే, కరెంట్ ఈజ్ ఫ్లోయింగ్ లైక్ దిస్, రైట్? ఇన్ సచ్ ఎ సిచ్యువేషన్, వాట్ ఈస్ ద కనెక్షన్? ఈజ్ అల్యూమినియం ఐరన్ in parallel state or series state?
Parallel.
Very good. Now please tell me how to understand aluminum resistance and iron resistance. Now let us take aluminum resistance. Yeah, tell me. What is common to all? Length is common. Length is common. So rho AL into length by area చెప్పండి ఒకసారి. Area of aluminum 7 square minus 2 square and millimeter కాబట్టి 10 power minus 6. Now please confirm, have you followed this or not? అరే ఓన్లీ అల్యూమినియం ఏరియా ఎంత? నాట్ 7 స్క్వేర్. స్క్వేర్ ఫేసే కావచ్చు, ఇట్స్ నాట్ 7 స్క్వేర్ కదా. అవుట్ ఆఫ్ విచ్ 2 స్క్వేర్ ఈజ్ ది ఐరన్ పార్ట్. సో యూ షుడ్ రిమూవ్ దట్. ఓకే, నెక్స్ట్, వాట్ ఈజ్ గోయింగ్ టు బి రెసిస్టెన్స్ ఆఫ్ ఐరన్? రో ఐరన్, లెంగ్త్ ఈజ్ కామన్. ఇప్పుడు ఐరన్కి ఏం చెప్తారు? ఏరియా చెప్పండి నాకు. ఐరన్కి ఏరియా 2 square.
2 square into
2
10.
square. 2 square into 10 power minus 6.
So how are they? Parallel. So very simple. What is the effective resistance? The effective resistance is rho aluminum into rho iron by rho aluminum plus R aluminum, R iron by R aluminum plus R iron. అరే మహంత్ చెప్పరా, ఇది ఐఐటి క్వశ్చనే. నేను ఇప్పుడు ఈ క్వశ్చన్ ఇప్పుడు I assume that I haven't discussed this, but did I cover the fundamentals required to this question or not prior to this question? Tell me. So therefore, every class is important. Every instant of the class is important. Who knows how that application is converted in the actual final exam? Please try to understand. Yesterday's class, my focus is strictly on basics. Today's class, 80% of my class is strictly on basics. Tomorrow, it is completely application oriented. Remember, I am the best in handling electricity track. Remember, and meeta cheppalenu kaadu, but I am telling you this. So therefore, don't miss a single class.